Okay, we're in section 15, homework. Again, what's homework? You do it at home. Again, this is what I would do if I were at home doing homework. Some people need to watch this before they actually do the homework, or they may do the homework and then watch it to see how close they are to what I'm doing. In the blue area, there are answers. Sometimes there's work, yada, yada, yada. Pretty typical of the notes. All right. I'm going to switch to the whiteboard and we'll do one problem at a time at the whiteboard. So give me a moment to do that. Okay, so I see problem number one there. And again, what does it say? It says, give a recursive formula for this over here. Recursive means it's going to be in terms of itself. So just writing this one down, I would say A1 is 1. I would say A2 is 3. I think you get the idea. A3 is going to be 7. Now, the question is, how are they related to their past? Well, if you look at it, there's many relationships, but what I notice is 1 to 3 goes up by 2, 3 to 7 goes up by 4. So then next thing you look at is well, how's it related to the past term? Well, this could get tough. I'll be honest with you, looking at it. And so I'm gonna make a stab at it. I'm gonna say, AN, right? In other words, if I looked at A4, how's it related to the past term? Well, I'm looking at A4. A4 is 15, right? And to me, it looks like it's twice the past. So twice the 7 plus 1. Now, is this true for this one? Is this twice its past plus 1? Well, 2 times 3 is 6, and 6 plus 1 is 7. Is this twice the past? I'm sorry, is 3 twice the past of its prior? Well, twice 1 is 2, 2 plus 1 is 3. So I'm going to say this looks good. So I'm going to say it's twice the past term plus 1. Before I commit to that, I want to look at it. Is 63 twice its past, which is 31? Well, twice 31 is 62, plus 1 is 63. Is 31 twice its past term? Well, 2 times 15 is 30, plus 1 is 31. Is 15 twice 7 plus 1? Yes. Is 7 twice 3 plus 1? Yes. Is 3 twice 1 plus 1? Yes. The only other thing I got to put down over here is the seed value, which is A1 is 1. So that's a recursive formula. We do recommend you look at the key and the key specifying that there. All right, what's this one over here say? Calculate the first 4 terms. Pretty easy, I guess. And what are the first 4 terms going to be? Well, C1 is going to be 3 to the first power over 1 factorial. And what's that going to give you? 3. We'll check with the key later. What's C2? It's 3 squared over 2 factorial. Well, that would be 9 over 2. What's C3? Well, that's going to be 3 cubed over 3 factorial. 3 cubed is 27. 3 factorial is going to be 6. This reduces, and I do suggest you reduce it. I'm going to say it reduces by a factor of 3, so 9 halves. What's C4? And they want the first 4 terms, by the way. We'll check with the key later. It's going to be 3 to the 4th power over 4 factorial. 3 to the 4th is 81. Yes, you have to build to arithmetic. 4 factorial is 24. Again, I'm going to reduce it. And it reduces by 3. That's 27 ace. Get my red pen out. C1 I said is 3. Good. C2 I said is 9 halves. Good. C3 I said is 9 halves. Good. C4 I said is 27 ace. Great. All right. Calculate the first 4 terms of the sequence starting with n equals 1. Well, they give me n is 1. That's pretty simple. So I'll put this over here. A1, A2, A3, A4. Well, A1's given. It's 2. Now, what's A2 equal to? It's twice, it's recursive, by the way, A1. Well, what's A1? 2 squared minus 2. What does that give me? Let's see. 2 squared is 4. 2 times 4 is 8. 8 minus 2 is 6. All right, what's A3? 2 times A2 squared, which is 6 squared minus 2. Now, a little more complicated. 36 times 2 is 72. 72 minus 2 is 70. This is going to be tough. 2 times, let's see, 70 squared, right? Minus 2. Well, I got to do that arithmetic, and I'll write this down for you. 2, I'm factoring a 2 out because it's easier for me to do that. Well, 7 times 7 is 49. So 4,900 minus 1. This can be 2 times 4899. Oh boy, I got to do that arithmetic, don't I? So let's take a look at that. Let's see, 2 times 4900, 8,000, 9,800 minus 2. That's going to be 99798. All right, I know mistakes happen. What I want to do is I want to go to my answer key. And I'm gonna box it for you. Whoops, I didn't mean to do that. I'm gonna take this, grab it, copy, and go to the next page. I'm gonna paste it in. And see how we did. Got the first term right. That'll be hard to get wrong, by the way. 6 is good. 70 is good. Did I get that last term right? I did. My arithmetic was okay. Typically, students who make mistakes in arithmetic try to shore up those skills in arithmetic, by the way. All right, let's go to the next page, which we're on number 3 now. Now, number 3, I know, and I'll give you a little warning here. I can't say it's comical, but it's almost comical. Typically on exams, we give almost the same exact questions, and it's surprising to discover on exams that students, it really, what's it, they can't do it on exams, probably what they've never tried the problem, right? And that happens to a lot of students. What I mean by that is very little engagement in their studies, not just in calculus 2, but it's happened over time. And what is happening over time, what happens to students is if they're little engaged in their subject area, yeah, their exams are going to be awful. All right, let's write this down. So let's write this down. I'm going to write these terms down. All right, so C1, it's all about you doing work. What's C1? We're looking at it. I'm looking at it's a sum of terms, right? It's really a partial sum. And what's going to be? It's going to be a quarter. What's C2? Well, it's 1/4. And if I put 2 there, I'd get, 1/7. That's not bad. We'll do that later. What's C3? Well, C3 is going to be 1/4 plus 1/7. And the last term, if I have a 3 there, would be 10. And what's C4? I know it's tough. It's going to be 1/4 plus 1/7 plus 1/10 plus, well, let's see if I'm at 4, what'd you get? 3 times 4 is 12, 12 plus 1 is 13. This one's done. This one, I got to get a common denominator, 28. Remember, if you can't do arithmetic, walk away. I really do mean that, by the way. This is 7 plus 4, which can be 11 over 28. That's going to be 280, right? Is that 280? No, let's see. 140, I'm sorry. I had to think myself. That would be 10 plus 20 plus 14. Did I do that right? Let me take a look. 140. Oh no, that's not correct. I gotta go back over that. I'm sorry. And let me erase this over here. I made a mistake. So how you make a mistake? I'm looking at it and say 4 times, what? Well, I gotta do this over here again. 280. And let's do that arithmetic now. What times 4 would give you 280, 140, 70. Plus 40 plus 28. That's really terrible, isn't it? Let's take a look at that. 280. And 70 and 40 is 110, 138. I'm going to divide by 2. And what do you get? 140. That's going to give you 65, 69. All right. I want to point out that I got that right over here, right? I've already done that. So really what I'm doing is 69 over 140 plus 113th. All right. Now, granted, I know it's difficult. What I want to encourage you to do is the arithmetic. If the arithmetic proves to be too difficult, don't do the arithmetic. But I got to do the LCD. So it's 13 times 140 Yeah, I know it's tedious. 1400. That's 10 times 140, by the way. 3 times 140 is 300, 120. Let's see, 300, 120, 420. So that's going to be 1820. I'll write that down over here. Yes, I know it's difficult. Then I got to do, I'll cross this out. I got to do 13 times 64. That's 640, 180, 192. That's 2, 13, 832 plus 140. And did I do that right? 13 times 640, 640. And then 192, 2, 7. Oh, I'm sorry. I think I made a mistake there, didn't I? 13 times 140. So if I did that right, 1820, right? 13 times 64. I think I did that right, 640. And 180, and 12, 192, 2, 9, that's 13. 832, I got that. And then 140, is it 113? Did I do that right? Yeah, let's see, 2, 7. I'm getting 972. I wonder if I made a mistake. I got to be really careful about this now. I'm saying 972. And what's over here? What I'm going to do, I'm going to just take my calculator and I'm going to try. I'm going to open up a calculator and I'm going to check myself. And this is what I would do in homework anyway. I'd say, I wonder, did that guy make a mistake? And I got to take my calculator out here. I'm going to add these things together. And what am I adding together? I got to get my calculator opened. Get up my computer. It wasn't open. That's why it's taken time for me to do that. I got to do something over here. Sorry for the delay. I'm just checking it. I'm gonna have to correct my notes, by the way. All right, 1/7. Someone says, why'd you use a calculator in the first place? You know, I think probably I should be practicing my arithmetic, just like you guys need to practice it. And what I mean by that is I just want to see if I got it right. I'm using a calculator now. And it's early for me. So let's see, 1/4, 1/7, 1/10. And I made a mistake. This is correct over here. All right. So I gotta figure out where I made the mistake. And I'm gonna write it down again. And I got the 1/4, 1/7, 1/10. I got the 69 over 140. I see it now. I wrote down 64. This is awful, isn't it? I'll point out what I did. And this is something you want to do when you're doing homework. You want to look at this and say, you know, I made an error in copy. And I wrote down 64 over here, and that's not 64. That's going to be 69. Let me erase this other guy over here. All right. And I'm going to correct myself. This is part of the learning curve, right? So what do you get? 13 times 140. I'll do that again. Getting better at that. 1400. 3 times 140 is 300, 120, 420. So that's 1820. Common denominator. 13 times 69. That's 690. And yeah, 10 times 69 is 690. 180 and 27. That's going to be 207. That's going to be a 7, 9, 897. And then when you get 140, 897 and 140, and you get 7 over there, 13, 1037. Okay, so I'm seeing the answer over there. Now someone said, oh, that's a waste of time. Why would you go through all that work? I'm practicing. I want to do well in exams. I'm trying to communicate to you as well. All right, so this one over here says, you know, calculate the first 4 terms of the sequence. starting with n equals 1, where Cn is the n place decimal of 2 times e. Well, I hate to say this, you're going to need to use a calculator. So you'd have to write down, oh, I would give it to you then. Let me point that out. It says don't use a calculator, but I would write down this for you. I would write down 2e for you. Give me 1 second to do so. So if I were given this exam, an exam question, I would write down 2e for you. All right, so let me put that down for you. So 2e, I would say it's approximately equal to 5.4, and I would write this on the blackboard for you. Oh boy, I hate writing these things down. All right. So what does it say? It says Cn, that's C1. So let's start at 1. N place decimal approximation. So what's that first number going to be? 5.4. I'm going to the first place. Now C2, what's that going to be? It's a second place approximation. A lot of people are going to write down 5.43. It's 5.44. All right, what's C3? Go to the third place. Again, a lot of people write down 4.436. It's not, I'm rounding. It says approximation, right? So it's 5.437. We'll look at the key later. What's C4? Well, I'm going out over here. Wow, a lot of rounding here, isn't there? 5.4366. Let me get my red pen out, see how we did. Got the C1, got C2, got this one, got this one. Feeling pretty good about it. All right, let me go to the next one. And over here, it says find a formula for the nth term of the following sequence, starting with the index. I gotta be honest with you. This one looks a little strange to me. Someone says, why look strange? Well, for one thing, I'm looking at the problem and I'm looking at these things and I don't see the fraction on the first term. So I'm going to write this down as 8. Oops, I'll get the black ink. I'm going to write the first one as 8/1, comma, minus 9/8, comma, 10/27. All right. So the first thing I want to notice about this, if I do write that down, I do know that they put this ... down. And the ... means it's predictable. Now, I think it is predictable, right? Now, you may not think it's predictable, but if you don't know the next term, it's going to be really tough to know what the pattern is. But I'd say the next term is definitely a minus sign, right? It's alternating, plus, minus, plus, minus. Now, if we look at the top number, I would say 8, 9, 10, 11. If we look at the bottom number, it's a little hard to predict, but I'm seeing it's 1, 8, 27. They look like perfect cubes to me. 1 cubed, 2 cubed, 3 cubed, 4 cubed. What's 4 cubed? 4 times 4 is 16, 64, right? So I'm going to say, yeah, it's predictable. Now what I got to do is write it down. So I'm going to write this over here. I'll check it, whatever I write down. So I'm going to write down AN is equal to, the bottom looks pretty easy to predict on. And if I'm starting with 1, it's just going to be n cubed. Again, I'm starting at 1. Now I'm going to say it alternating, so I'm saying minus 1 to a power. But the first term is positive, the second term is negative. So I'm going to say n plus 1. And that gives me alternating signs. Let me just check to see if that's true. If n is 1, I would get a positive number. If n is 2, I would get a negative number, so forth and so on. And then I got to worry about these guys over here. What do I notice about? They're going up. I'm sorry, they're going up by 1. They're going up by 1. So it has something to do with n. 1 times n. But to get the first term, I'd have to add 7 onto it. All right. I would suggest before committing to this answer over here, just to see if it works the first 3 terms. If I put 1 down there, what do I get? I would get 8 on top and 1 on bottom. If I put n is 2 down, what do I get? I would get negative 9 on top, 8 on bottom. If I put 3 down, what would I get? I would get 10 on top, 27 bottom. So I'm going to commit to this. Look at the key to make sure if you got that. All right. What's the next one going to be? Oh boy, it's another one. Oh, I'm sorry. I have to do this AN again. So I'll write it down for you. So AN. I know it's a fraction. Looking at the bottom, I'll do the bottom first. I'm a little better at this. The bottom's going up by 2, right? 3 to 5. So it has nothing to do with 2n. And I'm just doing the bottom first, by the way. Looks like 2n plus 1. Let me see if that's true. If I put a 1 down there, I'd get a 3. 2 would give you 5. 3 would give you 7. Let's do the top. It's also going up by 2. So I'm going to say 2n. Now, if it's 1, what would I have to add on a 3? Let's see if that works. If n is 1, I'd get 5 for the first term. 2, I'd get 4 plus 3 is 7. Yep, works beautifully. Again, look at the key. Make sure if you're getting that. And you're getting that. All right, so this one says, suppose you're given this limit over here, and as n goes to infinity, where n is an integer, the nth term goes towards 4 as n goes to infinity, and for bn, the nth term goes to 8. What do they want me to do over here? I guess use limit laws. So what do you go over there? Well, not that you have to write it down, but this is going to be a limit as n goes to infinity, an squared minus 2 times the limit. Let's see, n goes to infinity, an, and limit. And don't feel like you have to do this, by the way. N goes to infinity, bn. Well, do I know the limit of n goes to infinity, an? I sure do. It's 4, so it's going to be 4 squared. We'll do that later. 2. Do I know the limit? Yeah, I just did it. It's 4. It's given, by the way. And how about that bn? It's 8. Let's do the arithmetic. What do you get over here? 16 minus 64 is going to be minus 48. All right, go to the next page. Let's get the answer. And they got minus 48. All right, and they write that down for you as well. That's fine. All right, let's look at number 8 now. Number 8 says determine the limit as n goes to infinity. Fairly simple to do. I'll just write it down for you. And as I talked about, I realize there's a lot of work written over here. I'm going to not put too much work down for this guy over here. So I'll write it down, and it's limit n goes to infinity of 24 minus 6 over n squared. What happens over here? Well, nothing happens at 24, but the 6 is divided by an increasingly large number, right? Where's that number going to infinity? So in the limit, that term would be 0, so I'd get 24. On exams, that would be fine. You don't have to put all that work down over there. What I do is I do make sure you understand that I'm thinking back to what I did in Calc 1 for continuous variables, all right? Let's take a look. Oh, by the way, the sequence does converge for that. N goes to infinity again, fairly simple to do. I'll write this one down for you. Again, when you're in Math 119, they told you to divide by the highest degree variable. In this case, it's n. So it's going to be 8 minus 3 over n. I would suggest doing this, by the way. 15 plus 8 over n. And if n gets large, the top would become 8 and the bottom would become 15. So the limit's going to be 8/15. So this sequence also converges. All right, I see that over there. Okay, let's do the next one. And again, these can be a little bit tricky. I'm not saying they're not tricky, but anyway, I'm looking at this over here. And I'm looking at the limit. N goes to infinity. And I'm seeing 5/9 to the n. Now, what do I notice about this guy over here? It's a proper fraction. As n goes to infinity, this is going to shrink towards 0. The sequence converges, by the way. Let's do number 11, a little more complicated. Got a root in it, but I'll write this one down. Limit n goes to infinity. I'm going to divide, oh boy, I'm going to divide the top by n. So I want to point out n is an integer, and it's definitely greater than 0. It's an integer. So I'm dividing by, it's going towards infinity. Top would become 1. Now I want to point out, it's the same thing as saying, this thing would be equal to, if it's positive, it would be equal to this over here. Same meaning. All right. So let's divide the bottom by that. What are you going to get? Well, you would get n plus 10 over n squared. Now, I hope you realize looking at that, what happens to the top? It's 1. What happens to the bottom? Well, you know what? That second term does disappear. I mean, this goes to 0. But what happens? You have the root of an infinity, which is infinite, and 1 divided by an infinity is going to be 0. All right. So this series also converges and it limits 0. Let's go to the next page. What does it say? It says 0. Again, there might be a lot of work over there. And someone says, do I need to put that work down? I don't know. Maybe you do, but I don't think so. So let's take a look at the next one, number 12. These are relatively simple questions. Logs were taught to you in Math 119. I'll write this as a quotient, which is the natural log of n over n squared plus 5. I'm going to look at the limit now, and the limit as n goes to infinity of Sn. What's the natural log? And I want to point out, the inside of this thing over here, and I'll point out what I mean by this, is definitely positive term. So natural log is certainly defined in a positive way. So let's take a look over here. I'm going to go to the inside, and I'm going to say the natural log of the limit. I'm going to the inside now. What's the inside? N over n squared plus 5. And I know this is tricky, by the way. And this is n is going towards infinity. And it's going to be the natural log. I got to look at the inside now. And where's that limit going? Well, this limit here is going towards 0 from the right side, right? That's where that limit's going. Now it's going, and again, you learned about limits, certainly introduced in 119, and then you did it in 120, you continue with that, 121, yada, yada, yada. Let's see. What happens to the natural log when you approach 0 from the right side? It goes towards minus infinity. All right. Now I got this, by the way, this means the limit doesn't exist. We do want to see minus infinity, by the way. So what do I know about the sequence? The sequence diverges. All right. It's there, and you do see it says it's diverged over here. Let's do number 13. And again, I'm going to write limit down. And again, it's limit as n goes to infinity of Rn. This is going to be arctan. Arctan goes out towards, because this limit here on the inside is nice, limit n goes to infinity. The domain of arctan is all real numbers. And I'm going to wonder what this number is in here, if I can figure it out. And what's nice about this over here? Well, if you saw this limit over here, what's happening? N's going towards infinity. So this thing's going towards 0. All right. Now someone's going to say, like, what kind of numbers go to 0 from the right side? Right. So when you're going towards infinity, e to the minus 2n, right, it's going to be 1 over e to the 2n, and that's going towards, the bottom's going towards a positive infinity. So 1 divided by positive infinity is a positive number. That's why I'm saying it's going to 0 from the right side. Now, what's the arctan doing when you're going towards 0? All right, you should know the arctan from math 120. It's going towards 0. Let's go to the next page. You see this sequence converges, and I got the limit, and it converges. All right, let's look at number 14. Number 14 says, it's an arithmetic problem, and I have to, write down what they're saying. They say find the minimal number m such that an minus 1. Well, let me write that down. It's an absolute value, and that's n over n plus 9 minus 1. By the way, I don't like decimals, so I'm going to write that as 1 over, let's see, 1, 2, 3, 4. That's 1 over 10,000. I just don't like decimals. That's just me. It may not be you, it's me. So I need to solve that. And certainly, where'd you solve absolute inequalities in math 119? I got to figure this out now. All right. So what do you get over here? Well, I got to simplify what's inside that absolute value. It's n plus 9, right? And what do you get there? You get n minus 9. Well, it's getting tricky, isn't it? This would be minus 9 over n plus 9. I want to claim to you that this n, this is a sequence, and n's are positive numbers, right? So what number the absolute value of this thing? It's really simple. It's going to be 9 over n plus 9. And that's 1 over 10,000. Again, these are actually easier to deal with than what you had in math 119. Math 119, the x, could have been any real number except minus 9. Now we know that n is an integer greater than 0, right? That's what makes these things so easy to deal with. And since it's greater than 0, I don't have to worry about negative numbers in this problem over here. So I would get 90,000 less than or equal to 9. I'm sorry, n plus 9. Oh boy, I got to do some arithmetic over here. So what do you get? 89,991. I took away 9 from both sides. So what's the minimum value of n? The minimum value of n, for this to be true, is going to be 8991. Let's see if we got that right. And we got that right over here. All right, minimal value. All right, for this to hold. All right, not bad. All right, let's go to number 15. 15, oh no, it's one of these limit problems again. So kind of, I know it's stressful, but I have to write this down for you. And limit as n goes to infinity of n plus 3 minus root n. Now, I got to be honest with you. Some people says, are you going to put a lot of work down for this? Not really, because I'm going to say over here, the relative size of each of these terms as you go to infinity, they're relatively the same, so they're going to differ by 0. All right, but you know what? I get tricked sometimes. So what I like to do is I like to go through the work for you. So I'm going to put some work on the side for you, work. I'm going to look at this over here, and I'm going to do what I did in Calc 1. I'm going to multiply by the conjugate. And I realize for some students, this is overkill. And what do you get there? On the bottom, you just get n plus 3 root plus root n. And on top, what do you get? You would get n plus 3 minus n. Well, the n's cancel off. So I could write that down instead. So let me write that over there. Limit n goes to infinity. And you would get 3 over root n plus 3 plus n. Now, by the way, this is more clear to me. Why is that? The limit at top is 3, but the bottom is growing without bound very quickly. It's a sum of 2 infinite numbers. So the limit certainly is 0. All right, let's go back over here. I realize I put that in the continuous case for this thing. It's analogous to the discrete case. Its sequences are convergent. All right, it gets limit 0, by the way. All right, let's do this one over here. It's problematic, and I realize that. So I'm going to write down what I'm seeing over here. And this is going to be limit as n goes to infinity, and this would be 3 to the 1 over n. Now, what am I notice about this over here? And I'll point it out to you. N's going to positive infinity, so this would be 1 divided by infinity. So this would be 0 from the right side, right? This is going to 0 from the right side. Well, what's 3 to the 0? It's 1. Series converges. Let's go to the next one. And again, let's think through a problem. Let's take a look at this. Limit as n goes to infinity. I'm going to divide top and bottom by the root of n. So it's going to be 4, 7 plus 4 over root 7. I'm sorry, root n, I'm sorry. What do you get over there? Well, as n goes to infinity, I get 4 sevenths. Pretty simple. Again, I know there's a lot of work written down there. Sequence converges. Let's do this one over here, a little more complicated. And I'll write this down. Again, I know there's a lot of work there. I'm just going to think through with it. And what do you get? 5 cosine n over n. Yeah, I'd like to think. So what I mean by thinking is I'm looking at the top, and the top is bouncing around between plus or minus 5. It's going through all the numbers between plus or minus 5. All right, it's crazy. It's going up to 5, minus 5, in between those numbers. Where's the bottom going? The bottom's going towards infinity. So all these numbers, although there's a wide range of numbers over here, are going to be eventually divided by infinity. So it's eventually going to go towards 0. All right. Now, granted, I did use the squeeze theorem for that. You don't have to do that. All right. Let me go to the next page. Limit 0 and the sequence converges. I got this right over here. All right. You don't have to use squeeze theorem. Let me go to number 19. Relatively simple question, I think. And I'll write it down for you. Limit. Again, I'm thinking. I'm not doing a lot of work for these problems over here. And this is me doing homework, by the way. All right, let's take a look. Now, what's the top doing? The top, again, is bouncing around between -1 and 1. That's it. It either goes up, I'm sorry. It either goes to 1 or -1. It's only those two numbers. That's all it could be. What's the bottom do? Going towards infinity. Well, if you're dividing 1 by an infinity or -1 by infinity, it's still going to be 0. All right. What do you get over here? 0. Would I use squeeze theorem? No, you don't have to do it. Sequence converges. All right, let's take a look at this one over here. Limit as n goes to infinity of the arctangent 1 minus 6n. Well, again, I'm looking at, I don't want to do a lot of writing here, but I know, that the inside goes towards minus infinity. Now, you should know from Math 120, when you go towards minus infinity, the arctangent is asymptotic with minus pi. I'm sorry, let me go back to black. It's asymptotic with minus pi over 2. All right, let's go to the next page. See how we did. Minus pi over 2, sequence converges. All right, let's do this one over here, a little more complicated. And we've had, it's tough, but I'm saying it's not that tough. So limit, n goes to infinity, and I get n over 2n. Now, by the way, I certainly would like to think about it. Who grows faster, though? That exponential on the bottom is growing super fast. If you looked at, 2 to the n, it looks like this over here. If you looked at, the other guy, which is just a line, would look like this over here. The exponential grows super fast. It's going to overpower the top in no time at all. So 0. All right. Now, granted, you might say, what'd you do over there? I was doing something different using L'Hopital's rule. Well, you don't use L'Hopital's rule. Not necessary. All right. Sequence converges. All right. This one, it looks familiar to me. Right. It really does look familiar to me. And then the question is, why does it look familiar to me? It's a known limit. Right. This is a known limit. And what is that limit? I'm hoping you remember that this limit was introduced to you in Math 119. And that was a defining feature of A. So what's this limit going to be? Let me write this down for you. Limit as n goes to infinity of Tn is just going to be A. All right. It's a limit that you probably should know. If you don't know it, you know what? Maybe you should look it up. The next page. And I got that. And again, I went through a convoluted way of doing that. All right. When I say convoluted, I use L'Hopital's rule. All right. It's indeterminate form, by the way. And you can go through that if you want to. Oh boy, this one's another limit problem, right? So I guess I gotta do it, right? And I'm looking at it. Let's write this down. It's kind of complicated, right? Limit n goes to infinity. I get n, and then I get this root n squared plus 3 minus n. Now, probably I could answer this without any work at all, but let me just put some work down for you. I'm sorry. Let me see what I get. Limit that top is pretty simple, right? The bottom, these cancel off, and you get 3n on top. I'll write that down for you. And at the bottom, you get this. Well, I'm going to divide top and bottom by n. Oops, sorry about that. And by the way, n's going towards infinity. It's definitely positive. So n is equal to the root n squared. All right, so you get 3. The bottom would be, I'm divided by root of n squared, it'd be 1 plus 3 over n squared. And divided by n would be 1. So what do you get over there? 3. All right, let's go to the next page. Mistakes happen. Whoops, I did make a mistake somewhere. Let's see where I made a mistake. I'm sorry. The mistake, I said 3, and I apologize, but I looked at my key, but my work is good. I'm not saying the work is bad. What I do, I said something that's not true, and that's not good. So the limit at top is definitely 3. I said the limit at the bottom is 1. It's not 1. As n goes to infinity, it would be root 1 because this goes to 0, which is 1, and 1 plus 1 is 2. All right, let's go to the next page, and I'm seeing that over there. And again, they have work down there as well. All right. Wow, we are done. We're done. Now, granted, someone says, oh, you put so much more work down when you're writing your notes, by the way. And that's kind of true. When you're looking at either a textbook or, when people present information down, they're writing more work down. There's no doubt about it. And you want to get to that goal as well, where you're writing more work down. But I want to point out on exams, try to write down not too much work, but put down enough work, sufficient work to convince yourself that you're going in the right direction, all right? But if you're going to present information in a typeset form like I'm doing over here, please consider putting down more detail. It's important you do that. All right, thank you for your attention. And again, if you have questions or concerns about what's being presented to you, please bring it to my attention during office hours and we can discuss it.